Hi, Chem student. Have a good Monday. The question is science at the atomic level important? Obviously, we know the answer is yes, because the atom makes up everything, but let's get into it in more detail. So proton and neutron makes up the nucleus of the atom. They contain most of the mass of the atom because the nucleus is where 99% of the mass of the atom is. The electrons on the outside. Once again, please know, neutrons are neutral, has no electrical charge, okay? The mass of the atom is mostly proton plus neutron. That is the whole number identity of an individual atom. If you rearrange it, you can get N equal mass number minus P. The atomic number is the numerical name of an atom. So atom number 1 will be hydrogen. It will have an atomic number of 1. And it is once again based on the number of protons. So the atomic number is equal to the number of protons. Since the universe often is neutral overall, the number of positive proton will be equal to the number of electron. Please notice very, very well. When you look at the periodic table, you see the number of proton or the atomic number as a whole number. That is the numerical name for an element. You have the symbol and you have the name of that element in whatever language it is. Okay? Some language will vary a little bit. But most of the time, carbon will be carbon internationally. This number right here is the average atomic mass of all the different versions of carbon. The different versions are known as isotope. So when you average up a whole number, you will often get a decimal number. Once again, isotope are just different version of the same element. So different atom of the same element. Imagine two identical twins with the same DNA. One can weigh a little bit more, one can weigh a little bit less. Okay? They have the same chemical identity. They might have a slight differences in their nuclear reactivity level. When we measure the mass of an individual atom, we estimate it with a unit we call the AMU because it makes no sense for me to use gram since I will have a very, very small decimal number. So if I have 2 proton, 2 neutron, I would say the mass is roughly 4 AMU. 1 AMU is basically 1 proton or 1 neutron. Here I have 3 isotopes of hydrogen. The first one has 1 proton by itself. The second one has 1 proton again because it's still hydrogen. That's the numerical name, 1. And it has an extra neutron in it. And the third one is called tritium for 3 because it has 1 proton plus 2 neutron. They all have the same number of proton, making them all hydrogen. But their mass number is different. 1, 2, and 3 AMU. Okay, once again, here's a different way of showing it, and you can see it visually. This is the isotope notation that we're going to use in class to represent an isotope atom of a specific kind. The top number is the mass number. The bottom number is the number of proton or the atomic number. So there's different convention. The one that often is just written in the paragraph is just simply the element name with the mass number behind it. So with that element name, you already know the number of proton. But the one we will use, as I said, is the one that has a superscript in the front and a subscript in the front. Here is the main style I want you to know. I would write that down, circle it somehow, and we have some example right here. So how do you calculate the average atomic mass or the atomic mass of a specific type of element? Pretend about 150 years ago, one day you want to figure out the average atomic mass of the different version of copper atom. They analyze them and they try to split them up as best as they can. And they find out that about 69% of all the copper atom that they find in nature has a mass of 63 AMU. And around 31% of the copper atom has a mass of 65. So to calculate the average atomic mass, you need to remember that percent means part out of a whole or part out of 100. So they'll change this number into a real number, which is 0.69. And they'll change 31% into a real number of 0.31. Once again, of usually mean multiply. So when they say 69% of, that means multiply, and then 31% of multiply. Do what is in the parentheses first, punch it out, and you get a rough number like that over 100 years ago. Please know how to calculate this. You will see it on the test later on, and I'll do more example of it in class. So here's just another example for you to practice and try. We will go over this one on Tuesday in class. This is in your practice sheet. So you go to the periodic table and you can find the atomic number of a specific element. So by the fact that the symbol is Cu, I know it's copper, the atomic number will be 29. Using the rule that I boxed earlier, I know the number of proton is the same as the atomic number, and the number of electrons, which are negative, has to be equal to the number of positive proton, will be also 29. What is the mass number? The mass number will be proton plus neutron. 29 plus 25 will be 54, roughly, in this case. What will be the isotope notation for this specific atom of copper? It will be Cu. And the top number is the mass number, because that makes it unique, 54. And the bottom number will be the atomic number, 29, or the number of proton. Okay. Here I have an element number 53. So I go to my periodic table and I see that 53 is iodine. From that I know this is also 53. This is also 53. And the mass number is just those two added together. So 127, I believe. The isotope notation will be I. Top number is the mass number. Bottom number is the atomic number, or the number of proton, which is the same as the electron. Our last one here as an example is element number 95. I go onto the periodic table and I look for 95. And it looks like AM, named after America. So this will be 95. And this will also be 95 because A equal P equal E. I always say it spells the word ape. So easy way to remember that. The number of neutron will be the mass number minus the number of proton. So roughly 148. What is the isotope notation? It will be AM. The top number is the mass number. And the bottom number is the atomic number. With that, practice some of this. I'll go over this on Tuesday again. The worksheet is going to be handed out by our substitute teacher. Practice doing that. But just before I go, if you need help drawing an atom of a certain kind, just remember the rule is that the first ring can have a maximum of 2. And the second ring can have a maximum of 8. And then the third ring can have a maximum of 18. Okay. So if I need to draw electron on an atom that has, say, 14 electron, I'll have my nucleus in here. First one can have 1, 2. Next one can have 8, so I go 1, 2, 3, 4, 5, 6, 7, 8. And then I'll fill in the rest on the outside to get to the number that I need to. So if I, for example, have 15, I already have 10 here, I'll do 5 more on the outside. If you don't know or remember how to draw an atom, feel free to YouTube it. If not, I'll show you more on Tuesday. Have a good day.